Hello everyone, welcome to this session. I'm going to show you how to run a multiple linear regression with independent variables that are continuous and those that are categorical and are dummy coded. I have some data here, let me just show you the variable view. There are four variables here, importance, movies, gender, and classification, and we have their labels here. So we are going to determine whether the number of movies one attends each month can be predicted using level of importance of going to the movies, gender of participant, and class of the participant. So level of importance of going to the movies, let's just check its values here. We realize that it is measured on an ordinal scale, and we can treat it as a continuous variable. And then the number of movies attended, which is the response variable, is measured on a scale level. And then we have gender of participant, which is nominal. It has two categories, males and females. And then we have class, which is ordinal, and uh, it has five categories: freshman, sophomore, junior, senior, and grad student. So level of importance of going to the movies is a continuous variable, so we do not need to create dummy variables for it. Gender, uh, it is a variable with two groups, and its values are 0 and 1 already. This means that the current form of gender is already a dummy variable. So we just include it in uh, a multiple linear regression without recording it. For class, uh, there are five categories. So you see there are five different values, and so we need to create dummy variables to represent the variable class. We cannot just include the variable directly into the regression analysis. Let me just show you how we are going to record, or how we are going to create the dummy variables. So we will use freshman as the reference variable while doing dummy coding. So all the values will be 0 for freshman, and then we will have four dummy variables here: sophomore, junior, senior, and grad student. So sophomore was coded as 2, and we will now code it as 1, and all other values will be 0. Junior was coded as 3, we will code it as 1, all other values will be 0. Senior was coded as 4, we will code it as 1, all other values will be 0. And grad student was coded as 5, we will code it as 1, and all other values will be 0. Let's now proceed to do the dummy coding in SPSS. So it's very simple, just click transform, record into different variables. So we want to create dummy variables to represent class. So click class and bring to this box. And we begin with sophomore. Sophomore as the variable name. Let's give it the same label and click change old and new values. And sophomore was coded as 2. We are now coding it as 1. Click add, and then all other values will be 0. So write 0 there and click add, and click continue and click OK. We do the same for junior, transform, record in different variables, And now we have junior as the next dummy variable. Let's give it the same label. Change all the new values. And junior was coded as 3. Now code it as 1. And all other values as 0. Okay. Next is senior. So transform the code into different variables. Senior. You give it the same label. Senior was coded as 4. You now code it as 1. And all other values 0. And then the last one is grad student. Grad student is the variable name. Let's give it the same label. And it was coded as 5. Now we code it as 1. And all other values will remain 0. Okay, we have now done dummy coding for the variable class. If you check the variable view again, we now have 4 dummy variables: sophomore, junior, senior, and grad student, in addition to the previous variables. So let's proceed to run multiple linear regression. Click Analyze, Regression, Linear, and then the dependent variable is number of movies attended. Bring it to the dependent variables box. Then the independent variables include level of importance, gender, and the dummy variables sophomore, junior, senior, and grad student. Bring them to the independent variables box. And then click Statistics. Estimates and model fit are checked by default. Let's leave them like that. Let's check descriptives. Click Continue. Then under plots, we will check residual normality assumption. So check that box and click Continue. Then click OK. And we have the output here. The first output is descriptive statistics with mean and standard deviation for the variables. We also have N 447, which is the number of participants. The next table shows bivariate correlations, but we are much interested in the regression results. We have the model summary here, the ANOVA table, and the coefficients table. Let's begin with the ANOVA table. We have the F value here, 15.868, and its significance, or p-value. It's written as 0.00 here, but it's a very small number that is less than 0.001. So the ANOVA results here are statistically significant. This means that the number of movies attended each month can be predicted using a model with level of importance of going to the movies, gender of participant, and class of the student. So a model with level of importance of going to the movies, gender of participant, and class of the participant can significantly predict the number of movies one attends each month. If you check the model summary here, you can see the R square value 0.178 converted to percentage, it is 18%. Now this means that 18% of the variability in number of movies attended each month is accounted for by level of importance of going to the movies, gender of participants, and class of the participants. In other words, uh, the level of importance of going to the movies, gender of the participant, and class of the participant explain 18% of the variability in the number of times one attends movies each month. Okay, let's move to the coefficients table. Uh, we have the coefficients here, and then we have the t values here and the p values here. So level of importance of going to the movies, you can see the p value is less than 0.001. Junior, this is 0.001, it's less than 0.05. Assume that our level of significance here is 0.05. So these variables with p-values less than 0.005 are significant predictors in the model. So level of importance of going to the movies, you can see the p-value is less than 0.005. Junior, this is 0.001, it's less than 0.05. Senior, it is less than 0.05. Grad student, the p-value is less than 0.05. So level of importance of going to the movies, junior, senior, and grad student are significant predictors in the model. Gender of participant and sophomore are not significant predictors in the model because their p-values are greater than 0.05. So the coefficient for level of importance of going to the movies is 0.343. This means that a unit increase in the level of importance of going to the movies results into an increase in the number of movies attended each month by 0.343. I'm going to repeat that a unit increase in the level of importance of going to the movies results into an increase in the number of movies attended each month by 0.343. And then we have said gender of participant and sophomore are not predictors in the model, are not significant predictors in the model, that is. Let's move to junior. You see it's a significant predictor in the model. Now remember here that the reference variable is freshman. We used freshman as the reference variable or the baseline. So we are comparing these dummy variables to freshman. So we see the coefficient of junior is negative 0.536. Now this means that controlling for the stated level of importance of going to the movies and the gender of the participant, junior class attends movies 0.536 times lower than the freshman class. And then the coefficient for senior is negative 0.819. and it's a significant predictor in the model. So this means that uh, controlling for the level of importance of going to the movies and the gender of the participant, senior class uh, attends movies 0.819 times lower than the freshman class. And grad student, the coefficient is negative 0.828. Uh, and it's a significant predictor in the model. So this implies that uh, controlling for the level of importance of going to the movies and the gender of the participant, uh, graduate student attends movies 0.828 times lower than the freshman class. So uh, those results are in comparison to the freshman class. Now, assuming we just included uh, junior only in the model and we did not include sophomore, senior, and grad, then we would be comparing junior class to the other classes combined. Okay, uh, those are the results of the multiple linear regression. We have the PP plot here that is used to check the residual normality. You can see that the plotted points do not cluster along the 45-degree reference line. And so this means that the assumption of residual normality has been violated in this model. Yeah, so our session ends there. Let's meet next time.